It gives me great pleasure to welcome you all to this evening's webinar. Thank you for giving up your time. I'm Alison Skipper. I'm Veterinary and Research Advisor at the Kennel Club, and I'm hosting today on behalf of Dr. Joanna Ilska, the Genetics Research Manager. As you all know, the recent paper that she was the lead author on was published, was it 2 weeks ago, Joanna, now? Modern Pedigree Dogs in the United Kingdom Kennel Club, a journey through shifting population landscapes and demography. Hopefully you've all had a chance to read the paper, which is what Joanna will be presenting on this evening. She'll be sharing insights from 30 years of data covering over 11 million dog registrations across 222 pedigree dog breeds. We're now up to 224, but this is data from 2022. She'll explore key trends in population sizes, the characteristics of breeding dogs, and what those findings mean for future population management strategies. The paper explores how pedigree dog populations have changed over the past 3 decades. And while today's webinar is primarily aimed at researchers, it's open to anyone interested in the topic, and we're also very pleased to welcome a large number of breeders tonight. We know, as I've just said, attendees will have a range of backgrounds, so the session will focus on key findings rather than detailed research methods. And afterwards, we'll be putting the whole recording on the Kennel Club's YouTube channel, so if you want to revisit any part of the presentation, you can do so then. So thank you again for joining us, and without any more ado, it gives me very great pleasure to hand over to Joanna. Joanna.
Thank you, Alison, for a really nice introduction, and thank you to all of us, to all of you who joined us today. Before we start, I need to warn you that in this webinar, we are going to look at the pedigree dog populations through a scientific lens. So we are directing this webinar primarily at people working in the area of pedigree dog population management, such as international kennel club officials and so on. I have tried to minimize the jargon, but I will admit that I wasn't entirely successful. So if you're not a big fan of scientific talk, please don't worry. We will be producing more accessible content on this topic in the coming weeks. You are, of course, very welcome to stay with us today. And if you miss anything, as Alison said, don't worry, the webinar is being recorded and it will be placed on our YouTube channel in the health webinar series. So you can always go back and watch it again. As Alison said, the main content of this paper, of this webinar, is going to be devoted to the paper with the really big title. However, we will start with the general background and rationale behind the project, which resulted in this paper. We will cover the aims and scope of the project, as well as the methods we used and how we should be interpreting the results. Then we will move to the results of the actual paper and finally its conclusions. Now, in case you're wondering, this illustration here was generated by AI and is meant to show a future dog. I wanted to include this here because the goal of everything we do at the Kennel Club's health team is to ensure sustainable future of pedigree dogs. We do this by addressing issues relating to health, and you can read more about what we do for health on our website, and you can also watch a series of health webinars on our YouTube channel. However, we need to remember that selection for health is only possible if there is enough genetic variation within a breed. As such, our focus today will be broader. We will talk about sustainable management of the resources that are available within the pedigree dog populations, and in particular, factors which can affect genetic diversity. So what is genetic diversity and why should we care about it? One of the simplest definitions of genetic diversity is that it is a pool of all genetic variants that are present in the individuals in a population. Now, because of time constraints, I'm not going to go into the detail of what these genetic variants are. If you want to find out more, please have a look at our webinar on the science of DNA testing, again, on our YouTube channel. In pedigree dog world, breeds started with the genetic variants that were present in the breed founders, But over time, many of those variants were lost, first through closure of breed registries, and then a combination of population bottlenecks, random loss when not all animals are bred from, and then somewhat related, directed loss through selection. And it could be either natural selection or human-directed selection. In comparison, there are only two processes which introduce new genetic variants into the population. One of those is mutations, which produce new genetic variants within the population in each generation, but their contribution is typically very, very small. The other process is migration, so introduction of genetic variants from other subpopulations. Now, why do we need to worry about the high rates of genetic diversity loss? Unfortunately, we have seen time and time again across all species, from humans through livestock to wild animals, that high rate of genetic diversity loss is very dangerous to the survival of a population. It leads to a number of issues, often referred to as inbreeding depression, where we see an increase in deformities, new diseases, drops in fertility, and overall poor health. In extreme cases, inbreeding depression can lead to a complete extinction of a population. As you will note, I said that the risks are associated with the rate or speed of genetic diversity loss and not its absolute value. So let's say that this plot shows us the changes in genetic diversity on the vertical axis and over time on the horizontal axis in two hypothetical breeds. First, we have a purple breed, where we see that the diversity has declined over time, but the decline was relatively steady. Our red line, on the other hand, shows a population which started with very low genetic diversity, and to save it, breeders decided to bring in a completely new, unrelated number of dogs from a different population. We see that this had an immediate effect on the genetic diversity, which shot up massively. But unfortunately, this brought a false sense of security. And sadly, the breeding practices which followed that importation resulted in a fast and drastic drop in the genetic diversity again. And through a multitude of experiments and studies on a number of species, we know that the rate with which the genetic diversity is lost is far more important than the point-in-time absolute genetic diversity reserve. So despite the fact that both purple and red lines of breeds are at similar levels of genetic diversity today, the red breed is actually at a higher risk of suffering from inbreeding depression than the purple breed, because red lost diversity rapidly and over a relatively short time. So as we can see, the rate or speed with which the genetic diversity is lost is not set in stone. And this is actually good news, because that means that it can be managed to a certain degree. In our discussion today, the most important factors affecting the rate of diversity loss are population size and its trends, selection, and migration. The rate of genetic diversity loss tends to be highest in small populations and populations under strong selection, and populations which are isolated from other populations, either through borders or through closed breed registries. Therefore, it is crucially important that we balance selection for important traits such as health with the management of the genetic diversity. And of course, we can only do this if we have enough knowledge about the population we are trying to manage. As in any other domesticated species, breeders of pedigree dogs select for breeding those dogs which fulfill certain criteria. For example, breeders may be selecting dogs which will have the highest chance of producing healthy and strong puppies, and they do so by drawing from the wider breed population. The problem is that the decision of individual breeders may either safeguard or... I'm really sorry, I'll just close the door. My dogs decided to join the discussion. Apologies for that. Classic. They always know when is the best time to start working.
Don't worry, it happens to us.
Right, so back to our breeders who are selecting dogs for healthy puppies. So breeders draw from the wider breed population. And of course, the problem here is that those decisions that individuals breeders are making may either safeguard or risk the sustainability of those population resources. Now, some of the experienced breeders will have an in-depth knowledge of their own lines and maybe of a few other lines. Newer, less experienced breeders may have some information about their own dog, but what both experienced and novice breeders are typically lacking is the information about the entire breed population. Hence, there was a need for an up-to-date overview of the resources within breed populations so that policies and plans could be developed for the management of genetic diversity. And this is where the Kennel Club comes in. Being the oldest pedigree dog registering body in the world, the Kennel Club has a database including millions of dogs. And this database provides us with the ability to study the breed populations and their changes over time. The previous and the first iteration of population analysis based on the Kennel Club's data was carried out in 2014 and covered 215 breeds over the period from 1980 to 2014. The main results were the mean inbreeding coefficient and its changes over time, effective population size, and the distribution of progeny per sire and dam over 5-year blocks. The results were included in the breed health and conservation plans for a breed, and the cross-breed analysis was published in a scientific paper. The project we're discussing today, the Population Analysis 2022, repeated the analysis from 2014, but for 222 breeds, and we shifted the studied period to a slightly more recent one between 1990 and 2021. But expanding the number of breeds and shifting the period studied is not all that was changed. We have added a number of other parameters, such as the average relationships between recent dogs, effects of inbreeding on litter size, characteristics of sires, and a whole number of demographic parameters. Now, we have carried out a separate analysis for each of the 222 breeds, with the results placed in a new population analysis breed report. Those reports have been shared with the breed health coordinators, and this year we will be spending a lot of time discussing the reports and their intricacies with the breed communities, with the aims of developing breed conservation plans. But from our perspective at the Kennel Club, we needed to establish whether the results of these within-breed analysis indicate any general trends that apply to all pedigree breeds. And secondly, if that is the case, can we use them to shape management policies that the Kennel Club could apply to all breeds at once? So to answer these questions, first, we had to combine the results across breeds. We wanted to make absolutely sure that our findings were scientifically sound, and so we have written out the results in form of scientific papers, which undergo peer review. Now, the combining of the results across breeds was not as easy as it may first appear. The first option we considered was to combine all the data from all dogs across all breeds and treat them as a single population. But we realized that this wouldn't be very fair, as we have a huge disparity in the numbers of dogs per breed. In recent years, top 10 breeds contribute between 50 and 60% of all puppies born per year. So by following this scenario, we would be basically describing the population of the most popular breeds only. The other option was to first take the estimates we got from the individual breed analysis and then treat them as equally important. But this is also not ideal, as we have some breeds in which we have very little data. And so treating estimates from a breed with 30 dogs registered across 3 decades as equally important to estimates from a breed with tens of thousands of dogs registered every year is hardly fair. Luckily, we came up with the ideal solution, namely a meta-analysis. Meta-analysis is a statistical method which was developed to combine results from multiple studies which all aimed to address the same question by using different samples of data drawn from the same population. The results of these individual studies are combined, but with weighing which depends on the statistical reliability of the particular study results. The meta-analysis gives us the estimates for the single population from which the individual samples were being taken and tests whether the variability between studies is due to random chance alone. In our case, we are using the meta-analysis to test a hypothesis that there is a single pedigree dog population with different breeds being samples of that single population, and that any differences we may observe between breeds being purely due to random chance. Now, we did a little bit of filtering here to make sure that the samples or the breeds we were using are actually comparable. So, for example, when we were looking at the trends in population sizes between 1990 and 2021, we only used breeds which were already present in the country in 1990. So because of that, we had slightly different numbers of breeds we actually used in the meta-analysis. I will be providing information on how many breeds we use for each of the examined parameters, but for the details of the specific filtering criteria, you will need to read the paper. Now back to our hypothesis. If the hypothesis of a single pedigree dog population were true, we could then establish a single set of parameters and use it to develop management strategies to apply to all breeds. If, on the other hand, we find the hypothesis to be false, so we find a significant and non-random differences between breeds, this would mean that the individual breeds will require breed-specific management strategies. The type of the meta-analysis that we have used provides us with two types of results. First, we get a pooled estimate. If significant, it represents a parameter or trend that has been discovered for our hypothetical single pedigree dog population based on the results from individual breeds. Then we evaluate the variability. First, we check if it is significant, and if so, we check how much of that variability is due to true differences between breeds rather than a random chance. Now, with this introduction now finished, we're finally moving to the contents of our paper. Now, the amount of the results we produced in our analysis was actually way too large to put into a single paper. So today we're only going to talk about the first part of the meta-analysis, which focused on the demographics, purpose-bred and imported dogs and their use in breeding, and the characteristics of sires. We will start with the trends in population sizes. As you will remember, we have already said that the size of the population and its trend over time have an impact on the rate of genetic diversity loss, with small numerically breeds tending to lose genetic diversity faster than larger breeds. When we first calculated trends in population sizes, we did this on the number of dogs born per year, as you can see in the two example breeds here. So the vertical axis shows us the number of UK-born dogs, and horizontal axis shows the year of birth. The results tell us that the population of rough collies on the left declined by 110 puppies per year, whereas population of Afghan hounds declined by 13 dogs per year. So this is how the data was shared with the breed community in the breed reports, as it is more relatable. However, when we compare between breeds, we need to account for different overall population size. So instead of using change in the number of dogs, we converted the trends to a proportional change. In our example of collies and Afghan hounds, it turned out that both populations actually declined by 6%. It's just that collie was a larger numerically breed to start with. Further, while we were interested in the trends over the entire 3 decades, we also know that the world of dog breeding has been changing pretty fast in that time. As such, we also calculated trends in the more recent decade between 2010 and 2021. So first, let's talk about the entire period between 1990 and 2021. Out of 159 breeds we considered in this analysis, 123 breeds significantly changed in size, and nearly 70% of those declined. The changes we observed range between 11% decline in Yorkshire Terriers, to 22% growth in French bulldogs. So actually in those two extreme breeds, the magnitude of growth was larger than the magnitude of the decline. When we fed those individual breed estimates into a meta-analysis, we detected a significant pooled estimate for a single pedigree dog population, which showed that the population declined between 1990 and 2021, but the decline was small at less than 1% per year. Looking at the more recent period, we analyzed 184 breeds. The number of breeds with significant change in population size was actually a little smaller, indicating more erratic changes. However, of those with significant changes, a slightly higher percentage declined. We're even closer now to 70%. The trends ranged from 17% decline in Pyrenean sheepdog longhaired to nearly 35% yearly growth in French bulldogs, which illustrates, again, more drastic changes than when we consider the overall period. The meta-analysis of trends in this shorter, more recent period again detected a significant and declining trend for a single dog population, and this time the decline was a bit more pronounced at 1.3% per year, but still rather small. So our across-breed analysis of the population trends showed that the overall single pedigree dog population has declined over the last 3 decades, but the decline was small at less than 1% per year. The trends in population sizes were more pronounced in the last decade, where we saw more drastic declines, but also more drastic growth. Now, there are some additional factors we need to consider when we're interpreting these results. Firstly, we need to remember that the periods we considered included the so-called pandemic puppy boom, a sudden and drastic increase in puppy numbers in 2020 and 2021. Now, this has likely led to a lower number of breeds which achieved a significant trend in that later period. It may also explain the more drastic changes we have noted in the last decade versus the entire period. Now, we did consider whether we should remove these 2 years as an anomaly, but we ended up including them as weird as those 2 years were. The puppies born in that period still form a part of our dog population today. So what could be the cause of the observed decline? We know that the overall number of dogs in the UK is still high. As such, the decline we are seeing could be limited to either just declining popularity of pedigree dogs, or alternatively, decline in KC-registered pedigree dogs. We can't really verify this latter explanation, as it is incredibly difficult to obtain any information about non-registered pedigree dogs. But on the other hand, we do know that the numbers of designer crossbreeds have been increasing in the last 2 decades. So this points to a need for a very careful examination of people's choices. Why is it that designer crossbreeds are preferred? Continuing with the topic of the size of the population, we now move to the size of the breeding population, as described by the percentage of dogs used in breeding. This can be loosely related to selection. If you remember, we said before that population under strong selection, where few individuals are selected to become parents of the next generation, will generally speed up the rate of genetic diversity loss if not carefully managed. So in this section, we were primarily interested in more recent dogs, but we also needed to be sure that the dogs we looked at would have been bred from by the time of the analysis. As such, we focused on dogs born between 2005 and 2015. And initially, we looked at dogs of both sexes. The range we observed was quite large, from none of the 13 small Munsterlanders born in the UK in that period used in breeding to 46% in Jack Russell Terriers. So after combining the individual breed percentages in the meta-analysis, we found a significant estimate for the single pedigree dog population, showing the pooled percentage of dogs used in breeding was low at 14%. Next, we wanted to look at males only, and this is because it's typically males who have a larger impact on genetic diversity than females. We checked how many of the males born in 2015 were used in breeding across 177 breeds. Our range again started at 0%, with none of the males born in 9 breeds used in breeding. The lowest non-zero percentage was found in Samoyed, in which under 2% of 115 males were bred from. On the other extreme, the highest percentage of males bred from was found in German Pinscher, where 36% of males were bred from. The meta-analysis of the 177 breeds gave us a significant estimate for the single pedigree dog population, showing that the pooled percentage of male dogs used in breeding was just over 6%. Now, we have repeated the analysis also for our top 10 breeds, which we selected based on the number of registrations in 2021. We expected that in those largest breeds, the percentages will be more similar, and to a certain degree, we were correct. The range was smaller for the top 10 breeds than it was for the whole 177. But as you can see, there was still quite a bit of variation. So the range was from the minimum 3% of 3.6 thousand males in Golden Retriever bred from up to 11.5% of 7.3 thousand French Bulldogs bred from. Now, the meta-analysis of just those top 10 breeds, so meta-analysis representing a popular pedigree dog population, gave us an estimate that was actually a little bit higher at nearly 7%. Now, one could say that we would expect the percentage to be lower in the most popular breeds, which are here marked in blue. And to a certain degree, yes, we can see it here. We see the number of male dogs on the horizontal axis and the percentage of males used in breeding on the vertical axis. So we see that there's a huge variation in the smallest numerically breeds. In some of the smallest breeds, none of the males were used in breeding, and then, in others, the percentages were quite high. The percentages get a little bit more stable as we increase the number of males born, but still, we do see quite a bit of variation here in top 10 breeds. So the general findings here are that the percentage of males used in breeding in pedigree dogs is low, which poses a risk to genetic diversity. And the percentage is not strictly related to the numerical size of the breed. And of course, one could say that the trend in the population size is more important than the number of males born, with the expectation that breeds that increase in popularity will also have higher percentages of breeding dogs to meet the growing demand for puppies. And it seems that this could explain the results in a few breeds, such as in French bulldogs. However, again, this is not consistent across breeds. We have seen breeds that are apparently declining in popularity with higher percentages, and vice versa, breeds which are increasing in popularity with low percentages. So we need to ask ourselves, what are the causes for this? The first and most obvious explanation, of course, is that this reflects selection for health, temperament, and appearance. But we know that this isn't the complete picture, as we have all seen beautiful, lovely tempered and healthy dogs that are never bred from. Many dog owners have quite negative attitudes to breeding, potentially due to ethical concerns relating to overpopulation. I think that we've all heard the adopt on shop forgetting breeding. We also know that the routine neutering has been long seen as a gold standard of responsible dog ownership, which may further add to the reluctance to breeding. So this creates a difficult conundrum. We do know that there is a need for ethically and well-bred puppies in the United Kingdom. Our current research also shows that ideally we would like to see more dogs contributing to the next generations. However, this, of course, needs to be balanced with the high standards and knowledge of people deciding to breed from their dog. Now, this leads us very nicely to the next section of the results, in which we will look at purpose-bred dogs and their use in breeding. In this section, we start to explore why some dogs are selected for breeding to help us understand breeders' choices. So in this part of the analysis, we were trying to establish whether there are differences and trends in the use of dogs bred for Casey-governed activities. Anecdotally, we know that dogs participating in those activities are bred and owned by people in close networks of breeders, trainers, and handlers, who are typically either very experienced and knowledgeable, or if they are novices, they can easily gain the knowledge from other people in their networks. In contrast, owners and breeders of so-called pet dogs are a hugely varied community, with some deeply involved in breeding for the purpose of a family pet, with equal knowledge and devotion as breeders of dogs participating in activities, to novice and inexperienced breeders and owners with very limited contact with the dog world. Of course, identification of dogs bred for a particular purpose is not easy. We have done it by extracting lists of dogs which have achieved a stud book number in either conformation shows, field trials, agility, obedience, or working trials. We assumed that to gain this qualification, the dog was more likely to have been bred for a specific purpose of the chosen activity. We further defined purpose-bred litters as litters where at least one parent had a stud book number. Now, if you're interested in the details of these disciplines, I'm not going to go into that right now, but you can find more information on our website. Now, before we move any further with this, we need to make a massive caveat that this is a simplification, and we are very aware of that. We know that we could only assess dogs bred for a small number of activities. For example, we couldn't cover dogs bred for any of the protection sports, guide dogs, detection of police, and military dogs. Now, these dogs often represent an intensely specialized breeding pool, but unfortunately, records which would allow us to differentiate these dogs are not available to us. Further, we know that not all dogs bred for a specific purpose attain a stud book number for a number of reasons. And equally, there are some dogs which have achieved a stud book number, even though their breeding was not directed at a specific activity. So, in ideal world, we would have the information about all activities a dog participates in with the detailed rationale of the breeder for breeding a particular litter. Unfortunately, this is not available, and as such, we needed to use the data that we had. So we started the analysis of this subset of data by calculating the percentage of dogs in the entire pedigree in the electronic database for the breed that obtained a stud book number. Of course, we only considered here breeds where at least one dog was awarded a stud book number to make sure that breeds were eligible for this title. The range we observed spanned from almost 0% in Lagotto Romagnolo, where only one dog in a pedigree of 3,000 dogs had a stud book number, to a whopping 30% in Sealyham Terriers. Feeding the percentages of dogs with stud book numbers into the meta-analysis engine, we found a significant estimate for the single pedigree dog population at 5%. Again, we saw significant variability between breeds that was not entirely explained by the size. So with the largest breeds, again, marked in blue on this plot, we see that the percentages are generally lower, but again, they are not exactly the same. The lowest percentage in the top 10 breeds was actually French Bulldog with 0.7% and 2.8% in English Springer Spaniels. But then when we look at smaller breeds, we see vast variability in breeds with sometimes similar sizes. Now, next we wanted to see how popular are dogs with stud book numbers in breeding. We assessed this by looking at the percentage of litters born in the UK that had at least one parents with stud book number across 143 breeds. The percentages ranged between 4.3% in French Bulldog and 87% in Basenji. After feeding these estimates to the meta-analysis algorithm, we found a significant estimate for our single hypothetical pedigree dog population, which showed a high use of dogs with stud book numbers in breeding, with a pooled estimate of 48% of litters having at least one parent with a stud book number. The percentage of purpose-bred litters was lower in the top 10 breeds, as we said, with the pooled estimate of 20%. However, we still saw a large variability. We've already said that French Bulldog had the lowest percentage of all breeds, not only top 10 breeds. But the highest percentage in top 10 was Golden Retrievers, with nearly 37% of litters having at least one parent with stud book number. Now, I am a dog person myself, and I will be honest with you. When I saw these results, I was somewhat surprised with such high percentage of purpose-bred litters. So I started wondering, is this true for dogs we are seeing now, or is that an artifact of historic breeding practices? So to answer this question, we examined the trends in purpose-bred litters over time. We found that the popularity of purpose-bred litters declined in most breeds, with the largest decline of 14% found in Italian Greyhound, but we did see some exceptions, with Chesapeake Bay Retriever apparently showing nearly 18% growth in popularity of such litters. The meta-analysis showed that in our hypothetical single pedigree dog population, the popularity of purpose-bred litters declined by 1.6% each year. And the trend was more pronounced in the top 10 breeds, in which 9 out of 10 showed a significant decline, ranging between 1.4% in English Springer Spaniels and 12.4% decline in French Bulldog. A Golden Retriever was the only top 10 breed in which the trend appeared to be slightly positive. So more litters born to dogs with stud book numbers over time. However, that estimate was actually not significantly different from zero. Now, we were able to confirm an anecdotal belief that the breeds which grow in population size are typically expanding in the pet population. So the plot here shows us the trend in population size on the horizontal axis and the trend in purpose-bred litters on the vertical axis. So we do have a few exceptions here, such as Alaskan Malamutes or Chesapeake Bay Retrievers, but generally the plot shows us that the breeds which increase in size, so on the right side of the plot, such as French Bulldogs, Boston Terriers, Pugs, Italian Greyhounds, they experience a decline in the percentage of purpose-bred litters, so they are at the bottom of the plot. On the other hand, breeds which declined in size, so we're looking here now, such as Yorkshire Terrier, appear to have an increase in the percentage of purpose-bred litters. So by analyzing the data on dogs with stud book numbers, we found that although there are generally few of them, their use in breeding was historically high. However, it has declined over time, especially in breeds increasing in popularity. In contrast, use of dogs with stud book numbers in breeding increased in breeds which decline in popularity, suggesting that when fashion ends, breeders that remain with a breed tend to be more engaged with the Kennel Club's activities. So the conclusions from this part of the analysis that we are seeing a shift in the characteristics of dogs that are selected for breeding. In the past, breeders sought dogs which excelled in some Casey-governed disciplines. Nowadays, new key priorities are emerging, which are likely to be breed-specific to a certain degree. For example, we have seen that in some breeds, the popularity of health-tested dogs is now on increase, whereas in other breeds, selection for particular coat color seems to take priority. Now, one important point to remember here is that we did not distinguish between disciplines, and it is possible that if we consider them separately, for example, show populations separately from agility populations, we would be able to gain further insights. Now, the second demographic group of dogs we were interested in was imported dogs, their origin, numbers, trends in use and breeding. If we go back to the beginning, you will remember that we mentioned that migration is the only meaningful source of introducing new genetic variation to a population. So understanding the imported populations and their use in breeding is extremely important to us. In total, the electronic database of the Kennel Club contains records of 55,000 imported dogs originating from around 100 countries. But more than half of all imports have been imported from just 6 countries: Ireland, Russian Federation, Poland, Hungary, USA, and Germany. Now, our data has clearly shown that the number of imported dogs is closely linked to the legislation pertaining to importation of pets. This plot shows us the total number of imported dogs on the vertical axis and their year of birth on the horizontal axis. Now, the vertical lines here mark significant changes in legislation. So prior to 2000, dogs brought to the UK needed to stay in government-controlled quarantine kennels for 6 months. Since 2000, dogs could be quarantined at the breeder's house in a number of countries. However, the dogs still needed to be older than 8 months to enter the UK. Now, we can see that this increased the number of imports somewhat, but the increase is nowhere near what we saw around 2012 when the Pets Travel Scheme was introduced. With the 2012 changes to Pets Travel Scheme, puppies as young as 15 weeks could be legally brought to the country. Now, we have formally tested the change in the imported population size by considering the trends in 159 breeds. And out of those, 139 breeds experienced a significant change, and in all cases, the imported population grew over time, with the growth ranging from 2.2% in Tibetan Terriers and nearly 24% in French Bulldogs. After feeding those estimates to the meta-analysis, we found a significant pooled estimate for our single population, with a 6.5% increase in imported population size each year. Of course, from the point of view of genetic diversity, a more important question really is how the imported genetics contributes to the UK population of pedigree dogs. As such, we calculated the percentage of litters where at least one parent was imported. And because of the massive impact of the 2012 legislation, we divided our data into 2 periods before and after 2012. By employing the meta-analysis, we found that the number of import-bred litters increased dramatically from 6% before 2012 to 25% after. Now, we did want to test whether this increase in popularity was a one-off consequence of the change in legislation or whether the trend of increasing popularity of import-bred litters continued following the 2012. As such, we calculated the change in popularity of import-bred litters per year based on the period between 2012 and 2021. Now, we considered 171 breeds, and those breeds ranged between 31% decline in French Bulldogs to 55% or 56% growth in Jack Russell Terriers. The meta-analysis showed that in our hypothetical single pedigree dog population, the popularity of import-bred litters continues to increase by 8.4% each year after 2012. So these results are promising. By increasing the number of imports and their use in breeding, breeders are creating the opportunities for introducing novel genetics to the UK population of pedigree dogs. However, there are a few caveats we need to be aware of. As pedigrees for imported dogs are of limited depth, it is crucial to ensure that the imported dogs are truly unrelated to the UK population, deeper in the pedigree. Secondly, the benefits of imported dogs will depend on the overall structure of the global population. If there has been a long-standing and continuous and substantial exchange of breeding lines between countries, the benefits from imported dogs are likely to be lower than if the imported dogs were to come from a completely novel source. To help with understanding this, I borrowed this plot from Wang et al. Here you have the reference. It shows the distribution of the samples of German Shepherds from 3 countries. So we have UK in blue, Sweden in green, and Finland in reddish, I guess. You don't have to worry about what the axes show here, but basically the closer the dots are together, the more genetically similar the dogs are. So here we see that the population in Finland is sitting very close to both the Swedish and UK population, indicating that the Finnish population has had a long-standing exchange of breeding dogs with those 2 countries. But then when we look at Sweden in green and UK in blue, we see that there are some dogs that are similar, and those are also similar to the Finnish dogs. But also those two countries have lines of dogs that appear to be unique. So if we were to import German Shepherds with the view of increasing the genetic diversity from UK to Sweden, for example, we would be selecting these dogs or vice versa, going from the bottom of the Swedish cluster, going to UK. Another aspect we need to consider is how geopolitical situation is going to affect the exchange of animals. We have already seen that the legislation pertaining to minimal age for an imported dog had a massive impact on the numbers of imported puppies. But another example relates to political situation. Russian Federation has been a very important source of dogs imported to the UK. However, as of March 2020, the Kennel Club no longer accepts registration of dogs from Russia in response to the Ukrainian war. Now, all these factors impact on the numbers and readiness of breeders to bring new genetic lines to the UK. And so the management plans need to account for sometimes volatile changes in circumstances. Now, in the last part of our paper, we focused on sires. This is because sires typically have much larger breeding output than dams, and so their impact on genetic diversity can be very, very large. Specifically, we were interested in seeing whether we could determine any characteristics that would make sires more or less prolific. So we divided our sires into imported and national, and then sires with and without stud-book numbers. To check how important these characteristics are, we calculated the differences in the numbers of litters produced by sires in different categories, first within each breed, and then we ran these estimates through a meta-analysis. Now, I'm not going to go through every single comparison because there was quite a few of them, but very generally, our results for sires agreed with the patterns we have seen before for purpose-bred and imported dogs. So sires with stud-book numbers produce more litters than sires without stud-book numbers, and imported dogs produced more litters than national dogs. We were, however, able to determine here that the status due to stud-book number had a larger effect than whether a dog was imported or not. So the difference in the number of litters was larger. So these results were based on the numbers of litters produced by all sires in those categories. But what we are really interested in is the popular sires, so sires which have the greatest impact on the breed population. So here we looked at the characteristics of the 10 sires which produced the largest numbers of puppies born in the UK since 1990. We first looked at the average number of litters these sires produced as compared to the median number of litters per sire in the breed. The largest difference was found in English Springer Spaniels, with the difference between the mean number of litters among the 10 highest producing sires and the breed median being 219 litters. A meta-analysis of the differences in 175 breeds gave us an estimate of 35 litters, thus proving existence of popular sires in our hypothetical pedigree dog population. Secondly, we wanted to see whether those super prolific sires start breeding earlier than other males. So we looked at their age at first litter compared to breed median and found that the highest producing sires in our hypothetical single pedigree dog population started their breeding career at around 7 months earlier than typical for a sire. Next, we examined the characteristics of the highest producing sires in terms of whether they were national or imported and whether they had a stud book or not. As we now had a good expectation that the trends in those two categories have changed over time, we have looked at two subsets of highest producing sires. First, we looked at the sires which produced the highest number of puppies across the entire period since 1990. Then we compared those sires to the most recent highest producers born since 2015. So this plot shows us the results for the number of imported dogs within the 10 highest producers, with all-time highest producers shown in dark green and the recent dogs shown in lighter green. On the horizontal axis, we have a number of imported dogs within the top 10 highest producers. So we go from 0 to 10. And on the vertical axis, we have a count of breeds in which that particular number of imports was found. So if we look at the all-time highest producing sires in dark green, we see that there were 55 breeds in which none of the 10 highest producing sires was imported, and there were only 2 breeds in which 8 out of 10 highest producers were imported. So generally, we had few breeds where imported dogs were common in the top 10 highest producers of all time. However, this has changed when we look at the recent highest producers in light green. First, we see that the number of breeds where there were no imported dogs among the 10 highest producers dropped from 55 to just 16. We see an overall increase in the number of imported dogs among the top 10 highest producers across all breeds, with the largest number of breeds having between 1 and 4 imported sires. Now, this plot shows us the equivalent for sires with stud book numbers, where we see the opposite trends. Looking at the all-time highest producers in dark green, we see that majority of breeds had at least some dogs with stud book numbers among all-time highest producers, with the largest count of breeds having between 7 and 10 out of 10 sires with stud book numbers. This proportion dropped considerably within the recent dogs, where majority of the breeds had half or less than half of the 10 highest producers with stud book numbers, and none of the breeds having all highest producers with stud book numbers. So with these analysis, we have confirmed presence of popular sires in our data, with an average difference of 35 litters between highest producers and typical sire. We have identified some characteristics that may flag potential popular sires early on. So, for example, sires who start breeding early, sires with stud book numbers, or imported sires. However, we have also shown how these criteria have changed over time, with popularity of imported sires now overtaking popularity of sires with stud book numbers. By comparing the highest producing sires of all time and recent, we also discovered that quite often these two groups are highly related. Here we have an example from one very popular breed with thousands of sires and hundreds of thousands of male dogs. Despite such huge number of males to choose from, we see that among the highest producing sires of all time, one sire, number 9, was actually a sire of another highest producer, number 5. And that same sire, number 9, was a sire of 2 more highest producers born since 2015 and was a grandsire of the third. And this is very important, as this illustrates why the limits on the number of litters sired by an individual dog are actually not likely to help with genetic diversity. These limits would work if a popular sire was replaced by an unrelated random sire from the population. But if the replacement is the son, then we are actually shortening the generation interval and we are speeding up the rate of genetic diversity loss. There are further complications related to the 5% rule. Firstly, it doesn't cover the popular sires and the largest numerically breeds. For example, the highest producing sire in our dataset produced a staggering 381 litters, and yet at the height of his productivity in 1990 till 1994, he only, I'm putting quotation marks here, he only produced 2.5% of litters born in that breed. On the other hand, we have very small breeds numerically, where the number of litters is sometimes so small that even if each litter had a unique sire, every single one of them would exceed the 5% rule. As such, we do need more sophisticated methods of controlling the popular sires. With this, we have gone through most of the analysis included in the first paper. However, as you may have noticed, I only reported one part of the results. I have told you before that the meta-analysis not only provides us with the estimates for a hypothetical single pedigree dog population, representative of all breeds, but it also measures the amount of variability between breeds that is due to true differences between breeds. To understand the importance of this measurement, let's briefly talk about the theory of variability. We've said before that the underlying hypothesis of the meta-analysis is that we are looking at samples drawn from one population that is essentially one unit. So for just one moment, let's forget about the dogs and say that our population is a piggy bank and our 4 samples are 4 coins, each tossed 10 times. Now, if you ever played coin toss, you will know that although in theory it should always be half tails and half heads, in real life we often see some variability. And this variability is due to random chance, and it doesn't change the fact that in our population of coins in the piggy bank, we do have 50% chance of tossing either head or tails. So random chance is a normal thing. It happens in most walks of life. And actually, when we are drawing samples of a population, some degree of variability should be expected between our samples. But now, let's consider that our piggy bank contains a rigged coin. Let's say that our last coin has 2 tails. Sorry, I really like these coins. I don't know what they are, but they are beautiful. Now we increase the number of tosses to 100. With the first 3 coins, we get, again, some random variability, but our last coin, the rigged coin, with both sides showing tails, is obviously only going to give us tails. So this is no longer a random difference. It is a true difference in the coin. It is not like other coins. So our meta-analysis is still going to provide us with some estimate for the population of coins within our piggy bank. However, it is also going to detect a true variability between the samples. Now, side note, please do not check me on these maths. I provided that for illustration only. I did not actually run the meta-analysis on these numbers. Now, going back to dogs, I decided not to show you the variability results before, as they were so similar between the different analyses. We have detected significant variability in all of our analysis, and large proportion of it was due to true differences between breeds. So I have put these results in the table, and please feel free to come back to this webinar and to this slide, especially if you're interested. However, what I would like to draw your attention to is that for majority of the analysis, more than 95% of the variability could be attributed to true differences between breeds. Now, for any dog person who is with us, this is nothing new. We all believe that our own breed is completely unique, but now we actually have hard data and statistic to actually prove this. So now let's quickly put all these results together to consider how they affect the genetic diversity in our pedigree dogs. Going back to the beginning of our talk today, we know that the rate of genetic diversity loss is affected by population size and its trends, selection, and migration. We can now allocate our results against those 3 factors. Our declining population sizes clearly fit in with the first factor, although we should remember that the magnitude of our decline is rather small. The small percentage of dogs used in breeding and the presence of popular sires can be grouped together with selection, as they both affect how many dogs contribute to the next generation. So unfortunately, those 3 groups of results contribute to increased rates of genetic diversity loss. On a more positive note, we have shown that over the time studied, we have seen a large and continuing increase in popularity of imported dogs, which could boost our national populations through introduction of novel genetic variants from other subpopulations. We have also documented some other findings, like, for example, the fact that the popular breeds are primarily bred from dogs not participating in KC governed activities. And although dogs successful in such activities used to be popular in breeding, their popularity is declining or has declined over time. The success in showing when choosing a breeding dog was replaced by other criteria, such as health test results. We have also checked that the 5% limit on litters produced by a single sire is unlikely to effectively safeguard the genetic diversity, both due to issues relating to highly variable breed sizes, but also due to non-random replacement of popular sires commonly exchanged for their sons and grandsons. All these findings help us understand the broad picture of the KC registered pedigree dog demographics. However, most importantly, importantly, we have detected significant and very high true variability between breeds for all estimates, which clearly indicates that the most effective population management strategies must be breed specific and take into account the unique combination of circumstances they are experiencing, including different breeding cultures. So the conclusions of our paper thus are that we have derived a number of parameters which can be used to describe pedigree dog population in broad strokes, but the high and significant variability between breeds means that all management strategies need to be tailored to the needs of a specific breed. Now, this paper and its findings are only the first of the steps we will go through in our journey toward effective population management. I am working on the next publication, which will cover the next batch of the results and will again undergo peer review. We are also working on the development of new tools for the management of genetic diversity. In the meantime, we are embarking on a series of discussions with the breed communities. We will together work on the interpretation of the individual breed reports, which will reflect unique circumstances of each breed, and following, we will work collaboratively to develop effective management strategies. With this, I would like to acknowledge my co-authors. Poppy Ryan is our Health and Genetics Project Coordinator, and without her help, this entire project would not be possible. I would also like to thank Dr. Daniel Tolhurst, an Innovation Fellow at the Rosen Institute in Edinburgh, who kept my statistics on point and helped me to polish this monster of a paper. And finally, a shout out to the entire health and registration team at the Kennel Club for their help in understanding the data. And thank you all for listening, and I'll be happy to answer some questions.
Well, thanks, Joanna. That's a very impressive tour through and a phenomenal body of work, and very clearly outlined. I'm sure there'll be lots of food for thought for many people there. So just a reminder, please don't put your hand up because we won't be taking questions verbally. We'll be taking questions via the Q&A, which I'll integrate with the questions that we've received beforehand. We don't have any published questions yet, so while you're thinking about that, I'll get going on the ones that we had sent in beforehand. And the first of these was submitted by a standard poodle breeder, but I know that this also applies to many other breeds. And this person said, we have 20% of litters with an import parent in standard poodles, and some have only a 2 or 3 generation import pedigree, making it difficult to evaluate the import. Can the Kennel Club insist on at least a 4 generation pedigree? So this is a question about shallow pedigrees, which I know is a hot topic among very many breed communities.
Absolutely, and I completely share the frustration. I'll add here that my breed is Russian Black Terriers. We have massive percentage of imports and import bred litters as well. So I do feel the pain. Now, currently, we are unfortunately limited by the reciprocal agreements between the kennel clubs. So this is an international agreement that has been signed by everyone. And unfortunately, we do have to acknowledge the fact that not everyone is as lucky as we are in the UK, with the Kennel Club having considerable resources. A lot of the kennel clubs abroad are run by volunteers, and so their resources for expanding on the pedigree depth might be limited. So at this moment in time, I don't feel that the Kennel Club will be in position to demand an expanded pedigree for the imported dogs. However, there is a growing understanding of this problem. Even I don't know if you have seen, there was a paper published in the same actually edition of the paper where our paper today was published, which summarized the International Partnership for Dogs meeting from last year in Helsinki, and data sharing and large data was a big subject of discussion there. So we are thinking about ways in which we could improve that. But I would very much encourage the Poodle BHC to raise this topic on our forthcoming workshops, because we absolutely need to troubleshoot how we are going to address this problem.
Thank you. We just had a point in the chat which is highly relevant here in the Q&A from Owen McGregor. Just to clarify, has imported semen been counted as imported sires in this work?
No, it has not. An imported dog was treated only as a dog that is actually residing in the UK and was originally born in a different country.
So if it was a litter side with imported semen, it would appear as a native bred litter, would it?
Yes, it would.
Okay,
Yeah.
thank you. Thanks. That's a really good question, Olwen. Thank you. Okay, all right. So moving on to the next question beforehand. This is a question about bottleneck population issues. Can you explain bottleneck population issues and how best to address it in a breed?
Yep, no problem. So a bottleneck is basically a very drastic and sudden reduction in the population size, where we lose a large chunk of genetic diversity in one swoop. So now we have to distinguish that from a population that always has been small, because that is a different phenomenon. So here we are talking about a population that was quite sizable and something happened. Typically in history, we saw that for pedigree dogs, at least around the wars, for example, when people, well, Alison will have plenty to add here with her background in researching the history of pedigree dogs, but when people had to unfortunately prioritize feeding themselves over the dogs, the number of breeding dogs have drastically reduced. So now, from the point of view of genetics, this is a big problem, because basically all the dogs that remain in the population basically become founders of a new population that will come in the future. Because we have few of those dogs, it will uncover the recessives that have been hiding previously. So when we have large numbers of dogs, all of them will carry some deleterious recessive, but as long as the numbers are quite large, it's quite unlikely that you will breed two dogs which carry the same recessive. However, as you reduce the number of dogs and you start breeding them in close relationships, those chances of the recessives appearing are increasing. So we are at higher risk of suffering from inbreeding depression. So this is what bottleneck is, and what are the effects on the genetic diversity of the population. Now, how do we address this? That depends. Are we talking about a historical population bottleneck, or are we talking about something that happened recently or is happening now? So if it is something historical, then well, presumably the population has survived. We can suspect that something called purging selection actually helped to remove the recessives. So the recessives, the deleterious recessives, were first uncovered by the population bottleneck, and they were removed through selection, both natural and human directed. So if that happened in the past and the population has survived, then obviously we need to be aware of it. And we need to try and gradually increase our genetic diversity, sorry, by smart imports, or maybe in some cases outcrossing. But if it is historical bottleneck, the situation is slightly less dangerous than if we're looking at something that is happening now. So now, if we have a bottleneck happening to our breed right now, then first of all the breeders, all the communities across the world need to collaborate together. The goal is no longer, I want to breed a winning dog. The goal is we want to preserve our population. So we need to make sure that we are preserving as much of the lines that are still present in the population. We carry out planned matings. We ensure that we are not making the problem worse by using popular sires. Maybe we have to weigh the number of litters planned for specific dogs by the already present diversity in the population. So, for example, we have 6 dogs that that survived in a population, and 5 of them come from one litter, and the 6th one is from a completely unrelated line. So we wouldn't want to breed those 5 litter mates to the same degree as the other dog. Of course, we need to consider whether we have access to imports that could improve our situation, or are we talking about the international bottleneck? In that situation, outcrossing is one of the solutions that the breed might have to consider.
Thank you. It's a really comprehensive answer. So we've got a cluster of questions on outcrossing, so it leads on very nicely to take all of those together. So these are, when will the crossbreeding programs be considered as they already are in some breeds in some other countries? What opportunities are there for outcrossing out of breed? And similarly, should we release and allow the use of similar types of breeds more freely?
Yep. So first of all, I'd like to say that outcrossing is an option at the Kennel Club. But the way we approach this is our role is to support the breed communities. So if any breed is considering outcrossing, we are very much inviting them to come over to us and talk about this. Now, such inquiries are directed usually to me. And what I always say to people that are asking these questions is, first, think very carefully what you're trying to achieve, because I think that in some circumstances, outcrossing is seen as a just golden solution, or just outcross and everything will be fine. But it's a little bit more complicated than that. So we have both the genetic and human components to consider. I'll first start from the human, because that's, from my perspective, at least, it's a smaller, well, it's a massive point, but short to describe. So on the human side, we have to be sure that the breed community is in, at least in general agreement, that they want to do the outcrossing. Because if we don't have an agreement, if majority of the population is actually, if majority of the breed community is actually against outcrossing, we're risking a further fragmentation of already small population. So this isn't really going to improve anything at all. But let's say that everyone is on the same page, everyone wants to improve something in the breed, then we have to think about what is the goal. Are we trying to deal with a specific problem, health problem, for example, or are we trying to increase the genetic diversity? And the solutions to these two problems will be slightly different. So we have to know what we are actually trying to do and how we are going to do that to achieve the best success. And this is because we already know that outcrosses that are done, well, I don't want to, let's call it willy-nilly. So let's say someone outcrossed a dog once and then kept back crossing to the same breed again. That outcross is going to have very limited impact on the population. That is actually not going to improve anything on the large scale of things. So I think that both to ensure that we're improving things and actually to defend the outcrossing and the value that it has, it's really important that we know exactly what we are trying to achieve. So going back to the question, when is it going to happen? Well, that all depends on the breeds, on the breed communities. So I think that in the coming weeks and months, we have a number of meetings scheduled with breeds. I know that a few of them have expressed a gentle interest in outcrossing. I don't want to name any breeds because, yeah, that would be quite a risky political statement here. But we shall see what happens. It's very much on the table, and it depends on what the breed communities are trying to do. Now, also, I will, Alison, mention the webinar that you're going to have in June, I believe. We are going to have another webinar in which Alison will talk to us about the history of closed breed registries at the Kennel Club. I don't know, Alison, do you want to add anything here, or?
Sure, yeah. So this is really providing the historical context of why we've ended up as we where we are now. basically sort of explaining how the registry is closed, why, the fact that it was a more gradual process and with more scientific cause at the time than is maybe generally known now, and looking at sort of various elements of why and how things were done in the past and how that can influence our understanding of where to go with things in the future. So I'm going to be giving that in, I think it's the second week of June, isn't it?
I believe
Yeah.
so. Yeah.
Yeah. And then Joanna, I think I've seen your comment as well, Barbara, but Carol has just sort of asked very much the same question as the last part of the outcrossing one about opening up registration to the breeding of highly related breeds. So I suppose this is the sort of thing like mating across varieties of Dachshunds or Spitz or things like that, where there's a sort of obvious link between different varieties.
So yes, this is already allowed in several breeds. I don't want to put my foot in my mouth, but I believe we have that in Chihuahuas, and oh God, my brain has gone completely blank now. Yes, we do have that in two or three breeds already. So the precedence is there. If a breed community would like to have that considered by the Kennel Club, then by all means, please do get in touch with us. And considering that it's already happening in a few breeds, I don't really see why there should be any problems. However, that there is just one comment that I would like to make here. If we are talking about similar types of breeds, we need to be very precise about how similar exactly are they and how much of a benefit this is going to bring. So if we are talking about, let's say, two varieties that essentially are the same dog, but let's say one is long-coated and one is short-coated, then technically we are looking at difference in one variant. So although I absolutely don't have anything against that, I would question how much of an improvement some of those would bring. So it might be that if we are dealing with a population that is severely limited in genetic diversity, we might actually have to look a little bit further than the closest similar breed.
And the main reason I didn't help you out on which is because so many of them have been interbred or not interbred at different points in history. I wouldn't want to commit to which ones are currently eligible without checking either.
Yes, I believe that most of the Spaniels were quite widely interbred, widely, not wildly, interbred until probably like 80s, weren't they?
Oh, and some of them used to be the same breed if you go back far enough, exactly. Anyway, we're a little bit off topic for this evening. So Barbara, I'm not forgetting you, but yours is more of a human factor question. So I think we'll leave that for the end and just do some more of the technical stuff for a few more minutes. So one short, very technical one. Would average genetic relationship be a better genetic evaluation for breeding than coefficient of inbreeding?
Yeah, absolutely happy to answer that. For those who haven't had a chance to look at the breed reports, I've mentioned before that we've published the average relationships of dogs currently presumed to be alive. I guess this question is coming from someone who has already seen the breed reports. The answer is yes and no. The average genetic relationships and COI are targeting two slightly different issues. So with the average genetic relationships, we are going to select best matings for the breed. So we are, with the average genetic relationships, we can identify individuals that bring most of the genetic diversity into a breed, or vice versa. We can identify dogs that are already extremely common in the population. So from that point of view, the average genetic relationships are a better tool for the management of genetic diversity. In contrast, the coefficients of inbreeding, they're not going to do anything for the management of the genetic diversity of the breed. However, you will need to use the coefficients of inbreeding calculator to make sure that you're not breeding litter mates, for example. So let's say we have identified a dog that is extremely valuable for the breed, that there is only one other dog that is as unique as this other dog, and they are siblings. So if you just looked at the average genetic relationships, you'd think that, oh, that's a great breeding candidate. But then you check your COI calculator and you're like, oh, actually, no, I shouldn't be doing this, because even though for the breed population, this could be a great thing, for the litter, we would be actually creating a lot of risks for the prospective puppies. So it depends what we are targeting. I wouldn't say one is better than the other. They should be both used, both for the breed population and for the best outcomes in the litter.
Thank you. So a question that I think a lot of people will be interested in the answer to is what you explain very clearly the difficulties with the sort of 5% idea that's often bandied about with popular sires, but what numbers do you consider too many for one sire?
Well, I'm afraid that I will give that most hated response. It depends. Well, first of all, it depends on the size of the population that we are looking at. So what is maybe acceptable in Labrador Retriever is not going to be acceptable in Russian Black Terriers, and vice versa. Well, no, actually, what is acceptable in Russian Terriers will absolutely be acceptable in Labrador Retrievers in terms of the numbers of litters. But so we have the size of the breed population. The next one is, are we actually talking about breeding offspring or non-breeding offspring? So I think that there are additional aspects to this, but from purely genetic perspective, if a sire is producing loads of puppies, but none of them are bred from, then actually it doesn't count really, because he's not contributing to the next generation. So a dog that will produce 2 litters, but all of the puppies in those 2 litters are being bred from, is actually going to have a much larger impact than the other sire with 100 of litters and no breeding descendants. Another one will be, is that a sire that is already common genetically in the breed, or is that a sire that we newly brought in? So we always need to avoid popular sires, but there is a little bit of a give and take. So if we have something that is very, very unique, we might give them a permission for few more litters than sires that are extremely common, to kind of even out the lineages that we have in the population. And also one question, although this is not an justification for popular sires, but we do need to ask ourselves, why is that sire used so much? So if, let's say, there is a big health issue and that particular sire is clear for that health condition, then I'm not saying that the sire should be used, but we need to take note of the fact that he's used so much because of a health issue, and then think about other solutions. So there are many aspects that need to be considered. The best solution, unfortunately, at this moment, it's not yet available, would be using the average genetic relationships to judge the contributions of a particular sire and saying whether he's kind of showing in the common contributor or the unique one to the breed population. So I'm very much hoping that at some point in the future we will be able to offer that. Unfortunately, we're not there just yet. I'm sorry for not being able to give you the numbers.
Nothing's ever simple, is it?
No.
So we had quite a lot of sort of related questions that leads on to quite nicely about, sort of strategies for breed conservation and at tackling specific issues in the long term. And I don't think, unfortunately, we're going to have time to answer all of them. But the next one that probably will be of interest to a lot of people, again, is how can we work for long-term breed health in breeds that are suffering from extremely high genetic inbreeding? What practices need to be adopted and what practices need to stop? And in relation to that, does adhering to individual breeds coefficient of inbreeding targets affect breed health?
So going with the first one, how do we target long-term breed health in breeds with high genetic inbreeding? I will have a little kind of digression here. So when people use the word high genetic inbreeding, I'm assuming that they mean DNA-based genetic inbreeding. It is a bit of a pet peeve of mine because pedigree-based inbreeding is also genetic inbreeding. It's just that it's calculated on a different set of data. But yeah, it's a side issue. However, it is slightly important here because with the DNA-based estimates of genetic inbreeding, it's much, much harder to establish whether we are looking at old inbreeding or recent inbreeding. And as we've said before, the rate of inbreeding or rate of genetic diversity loss is actually more important than the absolute value at one point in time. So the first question I would like to answer, before I would think about management strategies, is: are we looking at old inbreeding accumulated over many, many generations, or are we looking again at something that has been happening in recent generations? Then the next question would be: what are the causes for such high rates of genetic diversity loss? Are we talking about a very small population, or are we talking about breeding practices? So we have some breeds that are relatively large numerically, but their genetic diversity is not great just because of the breeding practices that used to be used extensively in the past. So, these two breeds, the populations and those circumstances will need different solutions. Another question I would be asking: are we just looking at the estimate of genetic diversity, or are we already aware of some problems that are happening? So, for example, reduced fertility or autoimmune diseases. Because again, this is important to consider in our plans, how we are going to help the breed. So our breed reports that we created from the population analysis are providing the basics that we will be discussing with the breed communities, who will have, some of them will have information about the genetic inbreeding or DNA-based inbreeding coefficients. So we will be combining this information and thinking how we can actually move forward to improve the situation in the breed. Now, if we are looking at a breed that has been bred very smartly over many generations, we might get to a point where the inbreeding that we are seeing now seems to be quite high, but the population is completely fine biologically. So I would urge us to be careful with what we are changing. So first, let's identify the problem, and then we can develop the solution. Because just the statement that a breed has very high genetic inbreeding, personally for me, is not giving us enough information to say what we can do to improve the situation. Sorry, I think that there were other parts to this question, but I've already forgotten what they were.
I think you've covered most of that pretty comprehensively, and we're nearly at the end of our time. So maybe if we leave that one there. There are a few of the pre-submitted questions that I'm afraid we won't be able to get to. I'm sorry about that, because they were all really interesting, but unfortunately, we haven't been able to cover quite all of them. However, I did promise Barbara that we would answer her question, which is very similar to one that we had submitted beforehand. And she says: how do we increase the proportion of dogs used for breeding when the numbers of dogs kept by any breeder are generally reducing? We're losing breeders and not able to recruit new breed enthusiasts. And as she rightly says, there are a lot of things discouraging people from breeding small numbers of litters regularly. So do you want to have a first go at that, or do you want me to have a go, given it's a human factors one?
Well, I have to admit that this is a little bit out of my expertise. So I'm quite happy to tell you have a problem, and this is a part of a problem. I'm not entirely sure at this point in time how we would be addressing the human part of the change. But we do know that this will be a big part of the workshops that we are planning with the breed communities. And having spoken to several breed representatives already, I know that there are some really, really good ideas on how we can address this. We definitely want to make sure that responsible breeding with consideration for genetic diversity is recognized in some way. So yeah, my answer is not very meaty, but maybe it gives you some start. Alison, if you want to add anything.
Well, I think, Barbara, you've sort of begun to answer it yourself by saying that there's a lot of, there are many factors at play here. And I think, what the first step in solving a problem is to be clear what the problem actually is, or the problems actually are. And I think certainly there's much more awareness than there was both within the dog breeding community and outside it from other stakeholders interested in canine health and welfare, that ethical breeding is something that needs to be supported. To improve canine welfare overall, because one of the reasons that there are so many problematic breeders is that they're filling a need that there aren't sufficient ethical breeders to satisfy. And I think there's been a real shift in attitudes about that more broadly. It's certainly an area where the other branches of the Kennel Club, not the health team, but the public affairs department, are, working with government and so on to try and influence how future legislation is implemented and so forth. So I think that's very much a work in progress, and it's certainly too complicated a problem for any simple answers, but it's definitely something that's very much on the table for discussion broadly in the sector, which only has to be helpful, I think. So I think that brings us very nicely to the end of our time. I hope that everybody's enjoyed it. Thank you so much for giving up your time this evening. And a special thanks, obviously, to Dr. Joanna Ilska and Poppy, who helped her with this work, for their vast amounts of time spent on this really valuable and interesting project. So as we said at the outset, we've recorded this webinar, and in due course it will be available on the Kennel Club's YouTube channel. We'll send you all a link to this and a short feedback survey about today's webinar. You can also access our other health webinars via YouTube, with topics including common cancers, breathing issues in flat-faced breeds, back disease, epilepsy, breeding health testing, and many more. And please do, alternatively, if you'd prefer, feel free to email health@thekennelclub.org.uk with any further comments or feedback. So thank you very much again for your time. Enjoy the rest of your evening and the warm weather while it lasts, if you like warm weather. And we hope to see you at an event again in the near future. Thank you very much. Bye-bye.
Thank you.